Hello friends, let me welcome you all in our lecture series on IC engines and gas turbines. In today's lecture, we will be discussing about the operation of a two-stroke engine. For that, initially we will be discussing about the constructional details of two-stroke engine which are important from the understanding of a two-stroke engine. And then we will be moving on towards the actual operation discussion about the actual operation of two-stroke engine. So let us start. For that, first let us understand what a two-stroke engine is. As the name indicates, two-stroke means two-stroke engine means we mean to say two strokes are available for the operation of two-stroke engine. Now for that, we should understand what a stroke is. Stroke means the distance moved by the engine piston as it moves from one dead center to another dead center. And such two strokes are available for completing one cycle in case of a two-stroke engine. And we know that one cycle of an IC engine consists of four processes such as suction, compression, expansion and exhaust. In a four-stroke engine, since four strokes are available for completion of one cycle, purely one stroke is available for completion of one operation, and therefore the operation of a four-stroke engine is simple compared to that of a two-stroke engine. However, in a two-stroke engine, all the four operations has to be completed in two-stroke only. In order to understand how all the four operations are completed in two strokes, we need to first understand the construction of a two-stroke engine. So first let us start with understanding the construction, and for that we will be first comparing the construction of a two-stroke engine with a four-stroke engine. So a four-stroke engine is something like this. Here we have a piston cylinder arrangement connected through a connecting rod and a crankshaft. So the piston is supposed to move up and down, and the four strokes of this piston is available for completion of one cycle. And the combustion is happening over here, and intake happens through the inlet valve. That is, the mixture moves move in through the inlet manifold across the valve, and the exhaust happens here across the exhaust valve and through the exhaust manifold. Comparing to this, we have a two-stroke engine something like this. So here this is our two-stroke engine. Now here we have what we call as exhaust port, and here we have what we call as a transfer port, and one more is there which we call as the inlet valve. Now this piston is supposed to move up and down, and during the operation let us discuss the difference. So here we have the inlet manifold and inlet valve, exhaust manifold and exhaust valve, but here we have exhaust port and transfer port. So initially we can see over here, this is the region or the valve through which your mixture is supposed to come into the engine crankcase initially. So when the piston moves up, a negative pressure is supposed to be created over here in the crankcase, and due to the difference in the pressure, that is the negative pressure inside the crankcase and the atmospheric pressure outside, which is positive, the mixture through the carburetor is moving towards the into the crankcase. So initially the mixture comes in the crankcase, and which is then further supposed to move through the transfer port into the combustion chamber. So the suction is happening through the transfer port, and after combustion the burnt gases are supposed to move through the exhaust port. So in a four-stroke engine, the suction happens through the inlet manifold and across the inlet valve, and exhaust happens through across the exhaust valve and through the exhaust manifold. While here the suction happens through transfer port and exhaust happens through exhaust port, while we have different inlet valve for the inlet to happen. So inlet happens through across the inlet valve into the crankcase. So that is the constructional difference between a 4-stroke and a 2-stroke engine. Now let us move on to understand the operation of a 2-stroke engine actually. So this is a 2-stroke engine. We have here exhaust port, transfer port, and we have an inlet valve. Now let us see what is going to happen when the piston is moving from top dead center to bottom dead center. So the top dead center here and bottom dead center here. Now piston, we are assuming that it is moving from top dead center to bottom dead center. So initially we can see over here the piston is around nearer to the TDC, and theoretically we know that when the piston reaches TDC, a spark happens. So when the spark happens, the mixture starts burning, the combustion happens, and due to the pressure created inside the combustion chamber due to the burning gases, the pressure is created which is acting on the piston, and due to this particular combustion and the corresponding pressure on the piston, the expansion starts. So the during this particular expansion, the piston starts moving from TDC towards BDC. So the piston is moving from TDC to BDC, so it is moving down. So this is the effective expansion strokes moving from TDC to towards BDC. Now until the piston reaches over here, there is effective compression expansion happening, but the instant when the exhaust port is opened, now the pressure is being relieved since the gases are moving out through the exhaust port, and we say the exhaust happens. So now initially the expansion happened and then exhaust is happening. Now further as the piston moves down, we can see the piston has moved down. It has uncovered the exhaust port completely, and further it has also uncovered the transfer port. So once it uncovers the transfer port, now the mixture starts moving from the crankcase into the combustion chamber. So here we can clearly see that this both the suction is happening and simultaneously exhaust is also happening. Now what is actually happening over here? The mixture which is coming through the suction is pushing the burned gases available or present in the combustion chamber out through the exhaust port, and this process of flushing out the burned gases from the combustion chamber with the help of the incoming mixture, fresh mixture, is what we call as scavenging. So scavenging starts when the piston uncovers the transfer port, and it continues until this and this ports are covered. So further the piston here the suction is happening, and further the piston moves down, and you can see over here the piston has reached bottom dead center, and at the when the piston has reached the bottom dead center, we can clearly see that suction is still happening and exhaust is also happening. So in all, let us summarize what happens when the piston is moving from top dead center to bottom dead center. So as the piston moves from top dead center, first the piston starts moving down, so expansion starts, and the effective expansion happens until the piston reaches over here. So once the piston reaches over here and the exhaust port is opened, your expansion ends, and then further the exhaust starts. So exhaust is happening now, the gases are going out, and further the piston moves to uncover the transfer port, and suction also starts. So suction is starting now, and finally the piston reaches bottom dead center. So this is what happened when the piston was moving from top dead center to bottom dead center. Now let us discuss what happens when the piston is moving from bottom dead center to top dead center. So initially we assume that the piston is at bottom dead center and it is going to move up. So as the piston moves up, we assume that the piston is moving up and compression should happen. But since the exhaust wall is open, the compression cannot happen, and piston continues to move up. Now here you can see the piston has reached over here, but still the suction is happening and exhaust is also happening. Now when the piston uncovers the piston, sorry, when the piston covers the transfer port, the suction ends, but still the exhaust is happening. Now as the piston further moves up and covers the exhaust port, the suction also ends. Now the piston has reached over here, and further as it continues to move from here towards dead center, top dead center, your compression is happening. So the compression happens from the piston position here corresponding to this location towards until the piston reaches the top dead center. So now the piston has reached the top dead center. So summarizing, what happens when the piston is moving from bottom dead center to top dead center? So initially the piston was at the bottom dead center, the suction was happening, the exhaust was also happening, but as the piston covers the transfer port, suction ends, and as the piston covers further moves up and covers the exhaust port, the exhaust also ends. And now the compression starts over here. So this is the location corresponding to which the compression process starts, and the compression process ends when the piston reaches the top dead center. So finally piston reaches the top dead center. So that is where we summarize as the piston moves from top dead center to bottom dead center. Initially the expansion is happening, then the exhaust happens, and then suction is happening and piston moves down. While as the piston moves from BDC to TDC, the suction will continue until the transfer port is covered. The exhaust will continue until the exhaust port is covered, and then the the compression starts until the compression is happening until the piston reaches top dead center. So that is all about the working of a two-stroke engine. Thank you.